So this video is about the depletion type MOSFET. MOSFET are of two types, as you know. It is enhancement type and depletion type MOSFET. So the difference between these two is, in enhancement the channel is not created when the voltage is 0. It will be created when the gate voltage is applied. But in depletion type MOSFET, there is a channel between the drain and the source. So there is a pathway. So the movement of majority charge carrier takes place when VGS equal to 0. We'll see the construction of N-channel depletion type MOSFET. The depletion type MOSFET is two types, N-channel and P-channel. The same structure which we discussed in enhancement mode, but here in the presence of channel between drain and source. So as you know, there are three terminals: source where the majority charge carrier enters the channel, and drain where the majority charge carrier leaves the channel, and the gate which is isolated from the substrate, but drain and source which are diffused into the substrate. Since it is N channel, the substrate is P. The P which is having holes as majority charged particles, and it's a positive ions. In channel, it's a N-type semiconductor which is negative charged particle electrons. It's about the construction of N-channel depletion type MOSFET. So there is a channel existing between source and a drain. So we'll see the working of N-channel depletion mode MOSFET, and we use VGS and VDS, the voltage between gate and source and voltage between drain and source. So in enhancement, even though the VGS equal to 0, if you apply VDS, the current ID is 0, because there is no channel between source and drain. So no movement of majority charge carrier takes place in this condition. But in the depletion type, when VG is equal to 0 and when we apply VDS, the movement of majority charge carrier takes place, because the channel is existing and there is a pathway between source and drain. So here there are three cases. One is VGS equal to 0 and applying VDS in N channel as well as P channel. And next, when VGS equal to negative voltage and applying VDS in the presence of VDS. And then when VGS equal to positive voltage, means a MOSFET, it can work in both the polarity. So VDS is applied. So these three cases we are going to discuss with the characteristics. And in N-channel depletion type, here the first case is VGS equal to 0 and applying VDD. So here the positive polarity is connected to the drain, because the N channel which is having electrons as majority charge carrier, the electrons that will enter the source and it will exit from the drain. So the movement of electrons should happen only when the polarity will be attracted. So the positive polarity attracts the electrons, so the movement starts from source towards the drain, and negative is connected to the source, and Vg is equal to 0. So in this case, what happens is the electrons that starts moving from source towards the drain. So this will be the direction of movement of electrons in this condition. And if you see the output characteristics, when VD is equal to 0, ID will be 0, and when we vary the voltage across the drain and the source, the current varies, because the movement of electrons takes place from source towards the drain. So when the voltage increases, the current increases, and at some times what happens is the width of the channel will be pinched off. So that after the pinch off condition, the current will be saturated and will get the constant amount of current. So this is a characteristics for the condition when Vg is equal to 0 and applying VDS. And next is applying negative voltage to the gate. Okay, applying the negative voltage to the gate. So what happens here? We are considering only the gate terminal, because what is the effect of negative voltage in the gate terminal? And we know the substrate which is made up of p-type. The p-type which is having the holes as a majority charge carriers. Holes are positive charged. So this negative voltage that attracts the positive holes. So the holes will move towards the channel. And this channel which is made up of N in a sense, electrons are majority charged particle. So this electrons and the this whatever the holes attracted, okay, so this electrons and the holes will be combined. the electrons and holes ka recombination takes place in this negative gate voltage. So what happens is, when we increase the voltage, negative voltage VGS, when we keep on increasing, then the holes will get attracted and the holes will move towards the channel, and the electrons which is present in the n channel will be combined with the holes from the substrate. So recombination takes place and the number of free electrons that will be reducing. So when the voltage increases, the recombination increases and the electron number that will decrease. So that's what when if you consider this first value, when VGS equal to 0, this is same what we discussed in the last case. And when you increase the VGS value in negative scale, -1, -2, -3, what happens is the recombination increases and number of free electrons will be less. So when the free electrons in the channel gets decreases, that will decrease the drain current, because the number of electrons movement should take place from source towards the drain. So its number itself is less, then the DID, the drain current, will keep on reducing. That's what, when VGS increases, even the drain current decreases. So this is about negative voltage and its drain characteristics. And next, MOSFET also works in the opposite polarity. Means when the voltage is positive to the gate terminal, then what happens? The p-type holes that will be repelled. The holes will be repelled and the minority charge carriers, electrons, that will be attracted. So the electrons will be attracted by this positive gate voltage. So what happens? This electron will be added with the existing electrons. So the number of electrons increases, that increases the drain current. So if you see this brown color ka, this is for VGS equal to 1 volt, means positive voltage. When the voltage is increased positively, the drain current increases because the minority charge carriers will be attracted and it will move towards the channel. The number increases and the drain current increases. The drain current is more than the saturated current. So this is the drain characteristics for the case VGS is positive. And this is the transfer characteristics. Transfer characteristics is input voltage versus output current. So input voltage is VGS and output current is ID. So VGS is, we consider negative. This is a case that we said even the MOSFET works in the positive. So actually the VGS is in negative. So then scale will come in a negative VGS. So for what and all the values we discussed is -1, this one -1, -2, -3 and -4. The same value we are doing here and versus ID. So you will get the transfer characteristics. This transfer characteristics of depletion type is same like your JFET, N and P type. And next is about P-channel depletion type. I hope you understand the construction and working of depletion type N-channel MOSFET. And now depletion type P-channel means the substrate is made up of N and the channel is P. So it is a P-channel. The channel is P, which is having the holes as a majority charged particle and which is a positive ions. And the electrons, which is having majority as electrons. And gate, which is isolated from the substrate, and drain and gate, which is diffused into the substrate. Okay, this is about the constructions. And the cases are same. Like when VGS equal to 0 and applying VDS, here the negative polarity is connected to the drain because holes to be attracted by the negative. Means the movement of holes should happen from source towards drain. So this negative polarity attracts the holes. So minus VDS, VDS is in negative. Okay, so this, when we increase the voltage, what happens? When we increase the voltage, the more number of holes movement takes place from source towards the drain. So this is a case for VGS equal to 0 and applying VDS or increasing the VDS. So when even though VGS equal to 0, still the channel is existing between source and drain. So the movement of holes takes place from source towards the drain. And the characteristics for that case is this one VGS equal to 0. So when the voltage increases, current increases. After the pinch off, the current will be saturated. Okay, and next what is the next case we discussed previously? VGS equal to, here it is positive. Okay, what happens when gate voltage is positive? So when the gate voltage is positive, then that will attract the majority charge carriers, electrons. So plus and minus. So what happens? The electrons will move towards this junction, this channel. So this plus, okay, the holes will be repelled, isn't it? So this holes and electrons recombination takes place. So when the recombination increases, then the number of free holes decreases. So that decreases the drain current. So this is about this case. When we increase the voltage positively, 1, 2, 3 and 4, then what happens? The ID decreases. Okay, and next when we consider VGS negative, when we apply the negative voltage here, so what happens? This negative voltage repels the electrons and attracts the holes. So the holes will move towards the channel. So anyhow, the this p channel consists of number of holes as a majority. So in addition to this holes, this minority holes will be included, so that the number of holes increases, and when the movement increases, number of holes come, the ID, the drain current also increases. So that's what, when you apply the voltage in negative, what happens? It increases the drain current because the holes will be added to the existing holes, and the number of holes increases, then the drain current increases. So this is about the three cases. So here VGS equal to 0 and applying VDS, which is in negative scale, and next is VGS equal to positive, and next VGS equal to negative. So this is a respective output characteristics, and the transfer characteristics is same like P channel JFET. VGS is in positive scale. We consider VGS as positive versus IED, and we'll get the transfer characteristics in this way. So this is about the depletion mode. So enhancement mode, where the channel is absent and channel will be created by applying gate voltage. But in depletion mode, the channel is existing, therefore the movement takes place when the gate voltage is 0 itself. Okay, thank you.